Check. Yep, it works. Okay. All right. Well, it's 10:30. So let's get started. Thank you for coming to this session, which is on good. Yeah. On making use of some of the in-kind resources that are being contributed to Rubin, in particular the software, the data sets that are contributed, and also the data products that were produced along the way, and the independent data access centers and computing resources. We particularly want to know or have a discussion around how to make the best use of these resources. And so we're looking for input from you, the audience, and have reserved a fair amount of time for discussion. So yeah, get ready to share your thoughts. That is one advance. There we go. Just show the reminder slides here. You've seen these before, but yeah, just want to acknowledge that we're living through some pretty tough times, and some people have it tougher than others. So be respectful and kind and understanding of what people are dealing with right now. But I won't go into any more detail than that. For the virtual participants, there's guidance here for you to participate in the session. So please, be aware of this. Okay, right. So what we're going to do here is have some brief context on the in-kind program, with particular focus, as I said, on the computing resources, the software contributions, and data sets and data products. We also want to get some perspectives from contributors in this area. So we'll have presentations from the Polish IDAC team. We'll also have perspectives and lessons learned from the Canadian IDAC team, and some stories from in-kind contributors and users who have started making use of some of these resources. And then, as I said, a lot of the time is reserved for discussion. So a brief overview of the Rubin in-kind program. These are the way in which international teams are contributing to Rubin. They expand resources that are available to the Rubin community and can also offset some operations costs. And this map that Steve Margheim created shows the distribution of the partnership that's enabled through the in-kind program. And it really makes for a large and diverse scientific community that is contributing to this project. There are several aspects of the in-kind program. They're all listed here, which includes contributions to operations and facility enhancements, commissioning, and also telescope time resources for follow-up of Rubin discoveries and other things. The three that we'll focus on, however, in this session are the software development resources, the data sets, and hidden behind the Zoom message here, independent data access centers and scientific processing centers. So contributed computing resources. Okay, if you look over the distribution by value of all the in-kind programs, the value is significant in the hundreds of millions of dollars. And the three that we are talking about here, data sets, computing resources, and software development, comprise about half of that total value. So the amount of time and effort and investment going into this is significant. So the computing resources and computing centers, here's a map similar to the one that Steve created for the in-kind program as a whole, showing the Rubin data and the computing ecosystem, showing the locations of the data access centers in Chile and in the US, the data facilities that are contributing to the data release processing in France and the UK, and of course the US. And then the various independent data access centers and scientific processing centers around the world. And there's roughly 13 of these. Most of these computing centers are classified as light in that they don't, they only have a relatively small subset of the Rubin data that will be available at them. But it'll be some of the most scientifically interesting data that's there. I think the fact that these are geographically distributed is both a challenge and an opportunity. A challenge in that we had to move data around and deal with that distributed network, but also an opportunity in that it exposes the Rubin partnership to a really diverse, both culturally and experience, and in the kinds of services that they deliver. Really broadens the I think the availability of that to the whole Rubin community. And so each place will have their unique strengths and data sets and expertise. One thing that's really important is to understand some of the use cases for how these computing centers will be used. And so we've been working over we and you have been working over the past few years to understand that. So what these independent data access centers deliver, and I'll often conflate IDACs, which are hosting data products, and these scientific processing centers, which are mainly delivering computing cycles. Truth is that many of these centers do both. But they augment the resources, the compute, the storage that's available to the Rubin community by about a factor of 7 total, compared to what the rough 10% that's been allotted to from the Rubin computing budget to support science and user-generated data products. The idea is that they should be easily accessed by any data rights holder. It doesn't mean that everybody will start off with an account on every IDAC center, but the access is intended to be open. But they can be focused on particular science opportunities and collaborations, and we'll see an example of some of that throughout the session. They can provide support for other non-LSST data sets, which can augment the scientific opportunities for the Rubin data. And they can also support public sharing of LSST data once the data is public. So some of the questions that have come up over time, and some which remain. So that users might have when thinking about using these computing resources is what's available. So we have a spreadsheet of the planned data sets, the hardware and the services that's at this link. It's linked to our in-kind computing resource webpage, and it's maintained by the IDAC providers themselves. When will these computing resources be available? So the original agreement was that they would be expected to be in operation at the start of DR1. Of course, we heard yesterday that the schedule for what data releases will be available when is shifting. And so DP2, which is a significant data set, might be really of interest to a lot of these IDACs. But the agreement is for them to be in operation with the start of the first official data release. Several of the IDACs are already preparing to receive DP1 data as sort of a test case, and with the goal of delivering that to users. So we can talk about that. And some of the resources are already in use, as you'll see an example of in this presentation. So another question, so how will we use the computing resources? There is a fair amount of preparation that needs to be done in order for that to happen. So as mentioned, have been preparing thinking around use cases. We have a big list of use cases that have been proposed by the community, which is now a couple of years old. And could be updated, but there's lots of thinking about how to use these resources out there. IDACs and user communities have begun sort of starting conversations with each other about how to use these resources. There's been work on deploying the software and service layers that are needed, and work on testing data transfers. So one of the other things that I think we want to make it easier for users to see what's out there is some sort of dashboard which shows what's available. And here is a mock-up that Sierra has worked up. And do you want to come up and talk about this maybe? So introduce, this is Sierra Villarreal. She's, one of her roles is the IDAC technical coordinator.
So this is just a very prototype mock-up. I did it in Krita because I wanted to make it clear this is not anywhere near a final product. I hope that's entirely clear. The goal here is to make some sort of dashboard that will make it easier for scientific users to figure out what resources are available, what they might get out of specific IDACs, and make it easier for users to connect ultimately, and for you to also give out information to users. So I've kind of broken it up into, I think there's 4 main areas we're probably interested in. There's the status and logistics information, which is going to be, is your site up and such. Data information about what data products are hosted, which I'm not married to this forum. I'm not actually quite fond of it, but we need some way for users to know what sort of data products are available, since not every IDAC will be hosting the full data sets once we get into especially DR1 rather. Infrastructure information, because users might want to know about things of, do you have GPUs available? What sort of architecture do you have? There's a lot of different things that users might want. And then we sort of have like a random catch-all area. But this might take many forms. I'm really interested in hearing what people think we will need out of this. Some things that might come in mind is you might want a place to put notices if there's upcoming downtime you want to announce to your users. You might want to be able to just show what your current status is if the performance is degraded for some reason, or if you're open and ready to go for users. And honestly, just an onboarding page, because I think we all don't want to field the thousands of questions from users asking, how do I get an account at IDAC number 3? So it would be good to have somewhere where that's readily accessible to users and they can't miss it. And there's so much in columns that could be here that I've just made like a random grab bag of some infrastructure examples, but really this is a case of, we need to figure out what will best communicate information to our scientific users that they can figure out if they want to use your IDAC, just to maximize how much gain we get out of it. And then
thanks for that, and that's something that we could discuss in the discussion portion. Another thing that we're facing is that many of the IDACs have planned to receive what's called an object light catalog, which is the object catalog, but a subset of the columns to basically reduce it in size. And we don't yet have a firm definition of that. I love this, the message on the RSP website. I think it was Frosty probably that made this message, that we love every column equally, but just like we love all our children equally, but some columns are more important than others, right? And so here is an attempt to sort of categorize the nearly 1,300 columns that are in the DP1 object catalog. Roughly half are photometry related. There's a large number of shape columns, as well as astrometry columns and things like blending. If you look at the photometry columns, and you just take a look at the aperture photometry, there's something like 200 aperture photometry related columns, because there are 9 apertures defined times 6 filters, and you have values, errors, and flags associated with that. In fact, 48 of those aperture photometry columns are then duplicated as calibration flux columns. So I think there's, for an object light catalog, we could probably reduce the number of apertures that are reported in the catalog. There are different kinds of photometric algorithms. So, PSF, the Gaussianized aperture model, and Sirsic columns. This should be done with use cases in mind, but I think that could be reduced somewhat as well. In the shape columns, second order moments and extendedness columns are probably of use to almost everyone who wants to do star galaxy separation. But the higher order moments, which are 120 columns, I think are likely mainly of use to things like weak lensing science cases. And so this is maybe an area where we could reduce the number of columns and still have a scientifically diverse and valuable data product. And then likewise with astrometry, there are a number of WCS related columns, but then also in pixel coordinates. So there might be an opportunity to reduce some there. So I'm guessing that just doing this review, one could maybe reduce it by 50%. I think if you go further than that, you start to have to make scientific use case evaluation and judgment, which is hard. And just from a sizing perspective, these 1,300 columns of roughly 10 kilobytes per row. I think 8 to 10 kilobytes per row. And the object catalog will eventually have 40 billion objects, means that this will be something like a 400 terabyte catalog. Yeah, Nevin, use the. We do, yeah. I think you need to turn it on.
Yes.
I had to turn it on.
Jeff,
Thank you.
do you know where the 10 kilobytes per row estimate is coming from? It's not parquet, right? It's like.
No. So that I got 8 kilobytes by doing a query of the object catalog for all columns, and just the one row that I got back was 8 kilobytes.
On Butler or Tap? Or
On Tap.
On Tap.
Yeah. Mm-hmm.
I think parquet would be much smaller.
Okay. Yeah. Yeah. Question back there. Yeah. Sorry.
Would the object light photometry include the trailed sources, the trailed PSF?
Yeah. So far, I mean, it's just really a discussion of what we should keep in the object light. So I think it certainly could, unless those are in the solar system objects catalogs. Then I think those are relatively easy because they're quite a bit smaller than the object catalog. So I don't think there's an issue there. Yeah.
Okay. Yeah, that was my what I was aiming for, is the solar system
Mm-hmm.
ones. Thanks.
Okay. Yeah.
So the trail sources will not show up in the object catalog, because they'll disappear because it's based on the stacks. So there won't be any trail sources in the object catalog.
In the solar system object catalogs, yeah.
Hi, Nacho Sevilla from the desk. So is there going to be some kind of querying the scientific community or the science community for which comes to?
Yes, yeah. So I think at the past 2 Rubin community workshops, we had some discussion around that we need to make the object light catalog definition soon. So I'd volunteer to make a proposal that people can take shots at. Yeah. So that's the progress on that. Let's move on to the next part, which is software contributions, and the questions that arise out of that. So there's currently something like 90 international in-kind software contributions. Roughly a quarter of these are to the Rubin project, but 75% are contributions to the science collaborations. And it's one of the biggest in-kind sort of kinds of contribution. There are three varieties here: directable, right, where the developers are working closely with the recipient group. So in many cases, science collaboration members, and fulfilling need in a specific area. There is non-directable, where the developers are making a software product that has been deemed to be of value to the recipient groups. And then we have general pool, which is a pool of software professionals that people can apply to use for developing software products. We can, if you have questions about how to make use of that or any of this, you can talk to us, the in-kind team, or visit the in-kind pages. But wanted to probe with some questions, and we can either start talking about this now or reserve it for a bit later. Is that most software developed for the Rubin Science Analysis will be outside the purview of the in-kind program. So, and there's lots of other organizations that are working on software for Rubin Science and stepping up to the challenge of the scale. In the science collaborations themselves, through things like link frameworks, the LSSD Discovery Alliance, etc. We converged a Rubin software forum in 2023 to try to get some coordination of these efforts to look for areas where there might be overlap or opportunity to collaborate. But this requires effort, which I think hasn't really taken off. So some of the questions here are: do we still need a Rubin software forum? And then what are the roles for the computing resource centers in being repositories for the software that's developed? So what are the expectations, and are there some reality checks that we need to take from this? I'm going to propose that we maybe defer this conversation or discussion to the end, and go on to data sets. And Steve is going to talk about that.
So data sets are another one of these areas where the in-kind team is participating in a lot of contributed data sets to the in-kind, but what we control over is just a small portion of what is going to be used by the entire Rubin ecosystem. So in-kind contributed data sets are these products. They're not necessarily directed follow-up from things, but like that could either be existing data sets that are being that had proprietary use and now are being given access to Rubin data rights holders, or it is being something that is very specifically being going to be taken during the survey. Very data set to data set dependent on what the data set is, what format it's going to be in, where it's going to be held, and everything like that. So we want to make sure that there's sort of a minimum set of sort of quality and access for these data sets so that it's useful to the community. But we don't. Just a listing of some of these. Some of these are very sort of wide open stuff. So you have like the Ultrasat all sky UV maps. So this is when the first 6 months of Ultrasat's operation, probably in 2027, 2028. It'll be proprietary for a period of time. US or Rubin data rights holders will have at least 1 year of early access to that. So this is something that has general use. Things that are very targeted, sort of these Subaru PFS filler surveys, are very much targeted to the desk collaboration, to do photo Z things and stuff like that. They'll be useful to beyond that, and so the availability of that information needs to be able to be useful by people, but the design of the survey and things is very directed. And then some of these you even see software science development, and the lines blur between where the team is actually doing software development to derive a data product that then will be useful in terms of like matching up Vista or other sorts of data. So again, same thing that we talked about in terms of the software contribution. We, as the in-kind program, only have a slice of this and we're only really like directed on this. You know, how are we going to be able to make sure that these data products are available and useful within the resource limitations that we have? And, you know, what roles are there perhaps by these SBCs and IDACs into helping their communities get to this data to do that? So some more checks. And we now have a web page that has a little bit more information than just the table of these different contributed data sets, a little summary of them, and the primary recipients of each of these.
Thanks, Steve. Okay, so now we're going to move on to a couple of contributed talks to provide some examples of some of the contributions that we have been talking about and the lessons that they've learned and questions going forward. So first, I'll invite Agnieszka Polo to come up. Oops. There you go. Okay.
Thank you. Okay, so it will be just a brief status report, and in principle, it should not be given by me, but by one of these guys. So maybe next opportunity. And if you have two technical questions, I may have to refer to them because during the last half a year, I sadly had not so much time to be directly involved, but things are progressing, and this is a good thing. So, okay. Do it like that, or do I have some kind of switch? Okay, so like that it works. So the plan is that, yeah, I manage. So the plan is that the Light IDAC in Poland is a part of our in-kind contribution. It's managed by my institute, National Center for Nuclear Research, which is located physically near Warsaw. But the IDAC itself, at least for now, will be located at Poznań Supercomputing and Networking Center, which is a few hundreds of kilometers away from Warsaw. There are logistical reasons for that. For example, the fast transfer line from Western Europe to Poland goes to Poznań at this moment. Also, this supercomputing center has a part which is owned by our institute. So the IDAC will be still owned by us, but just associated with this supercomputing center. But also it opens an opportunity to collaborate and use the supercomputing center's resources, which may be useful in near future. So it's a part of a larger system, which also belongs to our institute, developed under some specific programs. There are some political subtleties there about how funding is distributed, but this is not important at the moment. The specification is as specified in the guidelines, CPU, storage, support, and the assumption is that we can serve up to 1,000 users in total and 250 users concurrently. So the present plan is that we will store light catalog data. However, there is a stronger and stronger request from the community that we also have images. So I guess all of you have the same problem, that what seemed to be not that necessary 5 or 6 years ago when we were initially planning this, now it's a necessity. Everybody wants to do machine learning on imaging data. So we may want to move to a bit expanded version. And for that, we even acquired some funding to have some extra storage and extra GPUs, which hopefully we manage to integrate with the IDAC soon. The architecture is more or less like that. The IDAC is intended to store our LSST data, to open a possibility to cross-correlate with other external data sets, and users will be allowed to use either Rubin Science platform or a simple multi-purpose Jupyter platform, which for some specific users or some specific purposes may be more convenient or more useful, or maybe they may be simply used to that. And then there will be place to store derived data. Now, the most important part is this slide. This is the current status. So the current status is that, first of all, for the initial setup, we have all the hardware in place. Most of that is already up and running, tested, and so on. The rest is to be set up and configured, but this is ongoing. Installation apparently went okay. So now what our team is mostly involved with or dealing with are security issues to make sure that the data will be appropriately secured, but at the same time they will be accessible to everyone that needs to access them. This is what's ongoing now. So the latest RSP is now running on hardware there, and it seems it works well. Currently, it's available for our internal users through our institute's VPN to access. Again, for security reasons, we will have to move to broader access, but for now we are conservative when it comes to tests. Data transfers using Crucio were successfully done, so this part is hopefully also manageable. And right now we are doing some functional tests using the data, and hopefully soon DP1 data when we manage to get them. So this here, the estimated time is really very close, and now it looks that technically we are ready to download and securely process the data themselves. The procedures to securely provide this data to the users are on the way of development. Some details still needs to be decided, but it looks like we are doing it always according to the general policy, and this hopefully is fine. And then our next plan would be to double resources at GPUs, enable to process images, but then we want to do it step after step. So This is the present status. This is the example how Rubin Science platform looks. So it locally looks hopefully okay. And in addition to that, we also are planning some in-kind software effort. Some of this effort is already ongoing and advanced. Some of this effort is not yet so advanced, but because we still need to sign the final version of the MOA to successfully apply for budget to employ people to do that. Okay, and this probably I was not supposed to show. This is how the whole setup looks like. So that's it. Thank you.
If there are any questions, happy to take them. So maybe just mention that thank you for giving the presentation on the IDAC. Since we have a dozen or so IDACs, I mean, I think this Poland has done great work in doing things like installing the Rubin Science platform and doing their planning. But it's representative, I think, of what's going to be available at a number of these centers around the world. So yeah, just to bear that in mind. Are there any quick questions? Okay, let us go on. Thank you, Agnieszka. Yeah. Yeah, so I think that, and then yeah, so next is Stephen Gwynn, who's going to talk about the Canadian contribution and lessons learned.
Hey there. So you may not have realized, but there's actually a contest to see who can get the most acronyms into their talk title. Good luck beating that. So CDC, Canadian Astronomy Data Center, CAMFAR, Canadian Advanced Network for Research and Astronomy Research, LSST doesn't need explaining, an IDAC neither. So the CDC, we've been around since the 80s, before data centers were cool. We had one. We don't just do LSST, we've been doing other Canadian telescopes like James Webb and Hubble, which have a Canadian component, and then CFHT and Gemini. The top panel of this diagram shows where all our data comes from, and then the bottom panel shows where all our data goes to in terms of downloads. And you can see it's most of the sky, and pretty much anywhere there's people on the world, people have downloaded our data. We're a few petabyte scale operation at the moment, but that's expanding dramatically as we move forward into the realm of SKA. In particular, is driving most of our expansion going forward. We also will be hosting Euclid data for Canadians, and then of course LSST. I'm now going to talk about the CAMFAR Science Platform. This is an introductory slide. It was originally built for ALMA processing, so for Canadian ALMA users to process their data. But once it was up and running, people from every other field in astronomy started using it within Canada. So at a recent, in the US, you have the AAS meetings. In Canada, we have CASCA, which is the same idea, except on a smaller scale. I gave a talk and I said, hey, Canadians, who's actually using the CAMFAR Science Platform? And more than half of the hands went up. So this is actually adopted as essentially the daily driver for Canadian astronomers to do their computing. We have one site that's been running for ages at the University of Victoria. Physically located at the University of Victoria, and the second site's going up at the University of Waterloo. This plot shows the growth of users over time. There's two mistakes in this plot. One is I computed it by looking at the seed time for the home directories of all the people on CAMFAR, which of course is not actually indicative of when things were created. And the second mistake I made is I tried to convey our technical innovation showing a SuperMongo plot, which is probably not the best strategy. And since I am a coward, I'm not going to go for the live demo, and I'm instead going to show you a series of screen slots. So if you land on the Campfire Science platform, you're presented with this. The panel in the bottom right shows how many people are on the platform, how many people are running jobs, what resources are free and available to be used, and what are already occupied. And then, so when I did the screenshot, there were 300 active sessions going on. Some of those are interactive, some of those are batch mode processes, and I'll talk about the batch mode in a little bit. But essentially everything's, there's 300 sessions going on. So there's probably, typically people have more than one session. So I would guess about 150 to 200 users were currently on the system at that particular point. When you want to launch a session, you have a choice of notebooks or the Firefly viewer that we have adopted from Ruben, or a desktop session that I'm going to talk about later. Carta is another image viewer sort of tuned to radio astronomy. I won't be talking about that. The next thing you would do is pick a particular kind of notebook. So there's containers. There's multiple software containers, not just one for everything. There's multiple different kinds that are organized by project. They perhaps need a bit of a shuffle at this point. But one of the key things here is it's not just things that we, the CDC, have produced. Users can contribute their own containers. They can keep them private to themselves, and only they would see them on this pick list. But the other thing that is very powerful is people share their containers so that people don't have to come and reinstall and build containers for their own software. They can, the usage pattern we see most often is there'll be one person who's a bit more technical savvy in a particular group. They'll build a container, and then the other people in that group will use that software container. You can then specify the resources, in terms of RAM and in terms of number of cores in a fairly granular way so that you can sort of adjust your computational request to your computational needs. So maximum of 200 gigabytes of memory and 16 cores. Yep. And then we do that, click send, you get a notebook, which I'm not going to talk about because they're fairly well known, but I'm also going to focus on the virtual desktop environment, which was actually the first one developed because it's most useful for the Alma users, where again, this is running your browser. This is, looks like an old Linux desktop, and it is, but it's running on our computers on a quarter of a CPU, and it's not the thing that you do work on. What you do the work on is you go to the applications menu, and then all those containers that were available at the start are now available to be launched as terminals within the session. And when you launch a terminal or you launch a window, again, you have the opportunity to select the resources available to that thing. It's now running in a separate container. So if you launch one of these desktops, you can open multiple terminals. They all have access to multiple separate resources running on separate physical computers, potentially. But all looking at the same file system in the background. So there's one container launched, or it could be TopCat if that's your thing. But there's sort of an awful lot of astronomical software is already available in that applications menu. And if it's not available, and you know how to build your own containers, you can make it available there. We also allow batch processing through headless jobs. So this has been proven extremely useful, so that if you want to do something that's non-interactive, you have want to do the same thing over and over again, that's possible through this system. So we have currently the job submission is by a RESTful API, so it's a little bit clunky. That's changing in the very near future. It has, however, been integrated by at least one user to work with the LSST pipe graph system. At the moment, users have to be very careful not to overload the system. So the first batch users were told, look, this is very powerful. With great power comes great responsibility. And that worked fine. And then they all talked to their students and said, this system is very powerful, but kind of left out with great power comes great responsibility. So we've had to do a bit of user education. We're getting rid of the user education stage in the very near future with this queue system, which will automatically enforce user fairness and make sure that people can't trash the system as the way they were in the past. Yep. So not just compute, there's also user storage. So there's two different kinds of Cavern, also known as ARC, is what you first get when you log on to the Campfire Science platform. You get a small default home directory. You can request a project directory, which could be multiple terabytes, and usually that's shared within a group. And that's sort of the home directory is locked down. Only you can access it. The group, the project directories are, well, you can control access and either make it, again, keep it to yourself, share with your group only, or world readable. And then there is the second user storage is Vault, which is suitable for data publication. So it's mirrored and backed up in long-term storage, but and a DOI is available through that system. Both of them you can either access with the ARC one, you can access just from the prompt, but it also has a VO-Space API, a Python client, and then a web UI where you can share things. And again, as I said, fine-grained access control for all of these. Where are we at? So we're building IDAC Lite. DP1 and DP2 will be available through Campfire. For each of the data releases themselves, we'll be hosting the co-added images. That's 2.7 petabytes. They'll be accessible via the existing CDC tools because that's the easiest for us. Originally, we're sort of not thinking about Data Butler because our users that we first queried said, actually, we don't want Data Butler. But then, of course, they started using Data Butler and now they like it. And so now we have to implement it. We will be hosting the object-like catalog. We're building out our database capacity extensively. And that'll be available through TAP, et cetera, and also through Firefly. And we're also looking to implement HATs with our colleagues down in Seattle. We'll be providing 3,000 cores for user processing and 2 petabytes of user storage. So we're providing that for one copy of all those resources for data rights holders. And then we're also providing, when the data becomes public, we'll be providing the same set of resources to the larger astronomical community. So there's my summary slide with a picture of the CDC. My office is in the bottom right. And I'll just leave it there and take questions. No questions. Nope.
Yeah, thanks both for the talks. It have been great seeing the progress being done in the IDACs. I had a question from the point of view of the science collaborations that at some point maybe wanted to test out some of these capacities, maybe with a user putting a container there, see how it works, some specific workflow that we wanted to test out the waters with that. Is that something that can be done already, or?
Yeah, absolutely. So let me just speak to the last point of the on the summary slide. Access for data rights holders is actually already available if you want to test it out now. By the time of DR1, we'll have the full ANA system set up where you come in with your Rubin credentials and you automatically get access to the CDC's resources that are set aside for Rubin. Right now, it's kind of, you just come in the same as a normal Campfire user, which is you get yourself a CDC account and then send an email to that support@campfire.net. And we will set you up with an with the allocation the normal person would get. It's not restricted at the moment to anything because we haven't got the quota system in yet. And you would have access to it right now. So thank you for reminding me. If you want, anybody in this room wants access, assuming you're all data rights holders, get a CDC account, which you can go to by Googling for us. I didn't put the URL up because it's horrible, because it's bilingual. And then drop us a line at support@campfire.net. Thanks.
Okay.
The question online is, I wondered about the level of granularity of container selection. Does that risk underutilization of resources as opposed to containers that scale CPU and RAM up linearly?
Excellent question. So a lot of users are good at guessing how much resources they need and do select the right resources. Currently, we found the 10 worst offenders who were asking for vast quantities of resources and not doing it, and sent them snarky emails saying, please scale your resources. That's step one. Step two is exactly what you just said, auto-scaling containers where you start off with the minimal things and then transparently to the users. As you use more resources get assigned to your container. So that is coming through.
Very, very good. Let's thank Stephen and move on to the next presentation. Right. So we've had now a couple of examples of IDACs, and we're going to move. Yeah, sure. We are going to move on to a couple of examples of users making use of these resources, and which I think might inform some of the discussion and the questions. So yeah, Tom Wilson, is it refreshed? Yeah, good. Okay. Is talking about his cross-matching in-kind contribution. So.
All right. Hello, everybody. How close do I have to be? Lovely. Yeah. So yeah, I'm going to talk today about our work in the UK, developing as part of my in-kind contribution, but then hosting as part of the wider in-kind contribution that the UK has with its IDAC, our cross-match service as a case study, as the title was presented to me. So first of all, the quickest I think I've ever given this talk in maybe 30 seconds. What is a cross-match anyway, just in case you aren't familiar with the term or the method, where essentially the idea is photometric catalogs, actually 50% of them is astrometry, is positions and corresponding uncertainties, my little black circle and the rainbow circles on the left-hand side there, of all of the objects that are detected by Rubin and the LSST pipeline. And what we want to do is the schematic on the right-hand side is take all of our black circles and then match them to our slightly funny yellow orange circles, depending on the color on the screen, and figure out what the objects that Rubin have detected correspond to in, say, the Vista dataset, or in Gaia, in SDSS, in pan-stars, etc. And we want to essentially globally optimize this problem of what objects are the same astrophysical object detected twice, and what are two different objects detected that correspondingly have flux upper limits in the other data set. And there's complicated maths because our algorithm is very fancy. It's Bayesian, and it uses the photometry to reject false matches if you need that case. It also does things like take into account crowding in, which will be a significant problem in basically all Rubin fields. Lots of details go into that one simple equation there. But you don't care about all of that. That's why I'm doing this job for you. Essentially, what you want to do is go to the Rubin Science platform and see a nice table, as I'm sure you're all familiar with, say, from the Gaia archive. There are association tables there where you get given the ID of the LSST object and the ID of the Vista object, and you want to do a join. So you go to the Rubin Science platform and you see something like this. A screenshot taken from the UK hosting of the Rubin Science platform. And this is our non-match table, just because that happened to be the first one to be loaded. But you'll see there are various columns, and then you can interact with them in SQL-esque ways. It's all hopefully familiar if you've used any other versions of these things or have been on the RSP before. But of course, there are many ways to interact with this. So we're also working as part of a link frameworks incubator and going forward with the link people to host this exact same data set, the same tables in LSDB, so that you can then, if you don't want to use the RSP and your framework is LSDB, then you can use these same things there. But you will get out of this not only the ID of LSST and the ID of your Vista dataset or your Gaia object, and then you can do your join. Because we have this slightly more complicated algorithm, slightly more fancy algorithm, you will get things like match probability, the confidence we have in the association between these objects. Match probability using just the position or the brightness of the object, because we match on astrometric and photometric grounds, and other stuff based on crowding, for example. So there's a whole host of other columns, essentially, that you will then be able to filter the quality of your matches based on this, again, in hopefully familiar ways. But actually then, as you start to think about this, at least for our particular methods, our particular setup, the question becomes, where does our in-kind contribution end? Where does the software development end? And where does the work that the IDAC does begin? And that's the interesting one that we've been thinking about in the UK. We've got this much wider workflow, starting with, at the simplest in the top left, we need to know what data sets people want matched together. Do people care about SDSS or do they want pan stars? Do you not care about doing an optical to optical cross-match at all and you want all infrared data sets? Do you want 2MAS because of the time baseline to get proper motions, things like this? So the community need to inform us running this service of what catalogs need to be run in the first place. So it begins there, goes through a whole bunch of things. There's complicated, the yellow bits are files, there's computers, there's all sorts of complicated bits on this workflow. But that's my bit. My in-kind contribution is in that very small circle. It's not a circle, it's a square. That shape, mysterious unknown shape up there, that's the bit that I do. That's the bit of running the software itself. So there's this much wider workflow around hosting, storing, understanding the data, there's validation. And then, obviously, as we mentioned before, things like security, you have to make sure that with data rights, unauthorized users can't access the data. But your other data set might also have a different set of data rights, such as Euclid. So you have to validate the fact that your user has to have data rights in both of your data sets, things like that. And as we've been finalizing the in-kind contribution, it's been being honed, we've had to start thinking about software sustainability. Because if the LSST is going to run for 10 years, and we're going to run cross matches between LSST and AN other data set times however many, TBD, please tell me if you want one. I say this in every talk I give. What data sets do people care about? Then the software has to run for a decade, which is a different problem that perhaps we're not yet familiar with in astronomy. It's a new problem to be thinking about on that timescale. So technically, I, as the in-kind contributor, am responsible for at least some software maintenance. But luckily for us, with the UK, we've got because we're working, very closely with the UK IDAC. In practice, they will be taking on the effort of maintaining this software. But it is a problem if you're thinking about software sustainability. How can you, as a postdoc, perhaps who's working on 2 or 3 year cycles, actually guarantee that you will be around to maintain your software for 3 or 4 funding cycles? But this involves things like the code has to compile, it has to run, software dependencies have to be kept up with. AstroPy had a big release, NumPy went to version 2, which anyone who works on software was a big deal, and you have to make sure that your compatibilities work. But if necessary, you can do containerizing, so you can just containerize the data, and you can just freeze these dependencies, and then your software should run, hopefully. Your hardware has to be migrated if necessary. Again, on 10-year timescales, the computers that you run on change, and we've had experience already of a fairly significant HPC failure during the in-kind contribution, which sort of gave us a view into this. And then if you have to move to a new software, you have to make sure that you've got your Fortran compilers, and does MPI run and all of these things. And again, the UK have to generate the data sets. If you saw, there was the left-hand side of that workflow before, where the data sets, the catalogs themselves have to be essentially reduced in some way to be given to the little software that's my bit, and then the outputs from that have to then be published on the DAC and then the RSP. So that then has to happen essentially at 11 times. But over 10 years, there's then corresponding with maintenance, there's improving, which realistically, the team that are involved in the UK and the DAC aren't astronomers, and they aren't necessarily software engineers. They are hardware engineers and things like that. So that we need more effort from a wider pool of people who aren't just the UK in-kind contribution or the UK IDAC. Things like we have to scientifically validate the output. The software will run and it will make results, but they might be gibberish. And we need astronomers to tell us in all science cases, galactic, extragalactic time series, whether these data make sense. If there's a major bug, that will require RSC effort to fix. If something happened that wasn't detected, that I did something wrong. And then if you want to extend these features, adding and then subsequently validating and testing new software features such as, I don't know, you want proper motions to be modeled in a particular way, you need some other feature in your probabilistic cross-match. So there's this tension between the in-kind contributor, the IDAC that's running the software, the maintenance and the development of the software. And that's something that we've sort of been thinking about. So that's our use case. Thank you.
Okay, thank you, Tom. Are there any quick questions? Yeah, in the back.
All the way. Kate steps in.
Thanks, Tom. It's really interesting work. If, for example, I wanted to change how I did the cross matching, for example, I wanted to add in proper motions into it to get a better estimate over a long time period, is that something that would be easy to integrate within your cross matching framework?
I guess it would vary as to how complicated, but I will probably say it wouldn't be as simple as you are hoping, if I'm honest. The code is quite complicated. It's not as modular as, it isn't just plug and play and infinitely extendable just by the nature of the way that the equations essentially come together. But it would be, and it is open source software that you could develop, but it's not fully modularizable, I guess. Actually, it was a bad example because we are planning to add proper motions as an extension to the thing, but yes, not as ideal as I think perhaps you're hoping, and that's one of the problems.
Okay, yeah, thanks. We are predictably running a bit behind, so if you do have more questions on this particular part, save them for the discussion session. But thanks. Yeah, or Slack, indeed. Yeah. Thank you, Tom. Okay. Yes, so next, another example of now using an IDAC for work related to the science collaboration.
Hey folks, as is probably fairly obvious, I'm not Megtron. I'm Tim Lister. I'm the software and community infrastructure lead for the Solar System Science Collaboration. Meg has asked me to say a few words about their work within the SORCA team on doing solar system calculations on the Bura supercomputer at the Croatian IDAC. So SORCA is an open source solar system survey simulator. So they are simulating all of the solar system objects that will be detected during Rubin. It's quite a heavy compute task. And it was suggested at LSST in Europe, in Croatia in 2023, that the SORCA team could use this Bura supercomputer as a potential pilot for a solar system IDAC, and this while the code was being developed to give them access to additional resources. And thanks to Bob Blum for making this suggestion. So the Bura supercomputer has 288 nodes. Each node has 2 Xeon E5 processors. So that gives 24 cores per node and a total of 13,000 threads. Each node has about 64 gig of memory and 320 gig of disk space. So overall, that produces a total of 18 terabytes of memory and 95 terabytes of disk. So plenty of compute and memory for running intensive jobs. So the Sorka team used Bura as another high-performance computing system. They have access to their own in the United Kingdom, but if they wanted additional throughput or those other HP centers were down for maintenance or other issues, they could use this, and they just logged on as any other user onto this supercomputer. They found that it was a very positive experience once they got over the initial sort of hurdles of how do you get onto the system and log in the right way. It was straightforward to use the Bura computer. It was useful for the Sorka team to use as another sort of test case. This helps you validate your code and make sure it works on different sort of platforms. And they could also use it to supplement the HPC facilities they had at their home institutions. This led to Bura being acknowledged in the main Sorka software paper, which is Meritatel 2025, which is coming out soon if it's not out already. And the Sorka team would like to give a big thanks and shout out to Tomislav Juric for getting everybody set up on Bura. So the idea is, could this sort of mode of operation be a model for some of the sort of smaller IDACs that don't necessarily have the resources to host petabytes of images or catalogs? So within the solar system, we have people who are interested in looking at the sort of pixel data and looking for extended objects and want to run, say, machine learning algorithms on GPUs. That could be another avenue that smaller data centers could provide. That could be a niche they could sort of fit in. But as the Sorka team showed, and there are other folks within Solar System Science Collaboration that are running dynamic simulations of trying to figure out where all of these bodies have come from and where they're going in the future. These sort of smaller IDACs could provide members of the science collaborations with access to an HPC, particularly for sort of smaller institutions who don't have the resources to run their own HPC cluster. It can also provide additional resources for those other institutions when pressure is high, big data releases sort of come out or something like that, or one of the other HPC sites is down due to maintenance. The science collaborations can implement mechanisms on who gets access to these resources. This may need help from the in-kind program as to sort of put subgroups of the science collaborations together with the IDACs to sort of grant access, kind of like a telescope access model, but to HPCs as well. And the Solar System Collaboration would love to have the Croatian IDAC become a Solar System IDAC available for members of the Solar System Collaboration. And it's a question of how do we move forward with this, from this sort of pilot model that was used by sort of Sorka to a more formal, long-standing one that provides stability for both sides. I think that's all I got.
Thank you, Tim. And I think that last question there, it's an excellent one. We started the in-kind, the IDAC and computing resource sort of program, somewhat concerned that given the distributed model of the network, that some of these computing resources would just sit there idle and not be used. The fact that they're being used in this way and the experience is good, and there's a feeling that they want to sort of make this into a formal relationship, I think is great. Now, Yeah, I think we've tried to approach this somewhat organically, in that we encourage, people to get together and start establishing those relationships with the computing center providers. And the degree to which we make that more formal, I think, is going to require a bit more thought. But it's a great question to raise. So, yep.
Sort of a question, but I'm almost answering a question that I'm self-hypothesizing. But essentially, is there any way the UK can help? Because this is, as these questions come to, people start to discuss this more. What's the word? The ideas solidify. I'm coming to realize that this is what we've been doing all along in the UK, just by the nature of, well, the UK's got an IDAC and I'm an in-kind contributor. I've been using effectively some of the cores of UK HPC facility to do exactly this. Is that a model that we can write up in some way, do something with? Can we help with moving people forward in this? Is this in this way? Is our use case helpful in this?
Yeah, it's a good question. And I don't really have an answer. I think it's really for discussion. Let me, I'm just going to move on to that slide. Yes. Yeah. So I think it gets to, thanks, Tim. Yeah, this for the remainder of the session, I want this to be an open, interactive discussion and put together a few prompts. You've heard some examples now of, what computing centers are delivering, what sorts of services they provide, and examples of actual use of these resources. And there's questions around, software and data sets and maintenance and longevity, et cetera. So given that, going to go to this first prompt and maybe take a minute just to think about how you might respond. So what are your expectations for support or availability for doing this computationally intensive work through the in-kind data access centers and processing centers?
I have just a general question, visiting IDACs here for the first time. In line with that first comment and this lady's explanation of the dashboard for all the IDACs, I interpret that to sort of suggest that if I want as a scientist to be a member of 5 of these IDACs because they're in line with some of my goals, if I would look at that dashboard, would I have to go through a separate or independent authentication to get to that data? Or does the mantra of use the RSP still apply?
Yeah, it's a good question. It's going to vary a bit from place to place. The one common element is that every IDAC, when they've signed up to contribute these resources through the in-kind program, have agreed to respect Rubin data rights. And that means being able to authenticate with your Rubin credentials to these IDACs. It doesn't mean that you automatically get an account on those places, but you'll be able to use those credentials. So there is some uniformity there. Some of the IDACs are, as you saw from the Poland presentation, are offering an RSP interface, and so to their resources, but not with all of the underlying software and hardware that you would have at the US Data Access Center. So there's going to be some diversity that really is informed, we hope, by the use cases that those centers and the user community want to run on those centers.
Okay, so not total uniformity, but some form of consistency. Now, once I get approved to access an IDAC, Are some of them requiring a subscription and a fee and that sort of thing, or?
There's no fees, right? So
Okay.
these are,
That's what I
these,
thought.
yeah, these are resources being contributed. So they do cost money for the IDAC providers, but in return, they're getting data rights, right? So they're
Okay.
getting the ability to use the data. So it doesn't cost the user anything.
Thank you.
Yeah.
So within the solar system collaboration, there has been some users that are very keen to get access to GPUs for running machine learning inference and for image pixel analysis for extended objects. We've generally not had any commitment from Rubin project to support GPUs within RSP. So the question is, where do the people who want GPUs go to? I don't wish to give any more money to NVIDIA, but there are people that do want to do this sort of thing.
Yeah, you saw in the Poland presentation some ambition, I think, to provide GPUs. It's not decided yet, but there are some IDACs who have committed GPUs already. Denmark and Australia in particular. And Barcelona as well. Great. Yeah. So that capability will be there. Yeah.
I was just going to go back and add a little bit more to to your answer to the previous question from over there. So my understanding is that the commitment to provide IDAC resources to the full data rights community, strictly speaking, switches on for data release one. So between now and then, it may be somewhat more ad hoc, or there may be some variability in terms of how individuals or science collaborations might get access to IDAC resources in the context of the data previews. And of course, the data rights still apply to data preview data, but there may be other more sort of, again, ad hoc ways of respecting those before DR1.
Yeah, thanks for that point.
Yeah, so it's an ongoing discussion within the IDACs, how to do authentication and authorization consistently across the whole network. I think we're going to have a plan in place by DP2, but there's, it's not right now. So 6 months from now, ask the same question, you'll get probably a very different answer.
So circling back to your original question for a moment, from the dark energy science collaboration, one thing that we have come to realize in the last couple of years is that we have mounting needs. We have mainly these needs supported by NERSC, but at some point we're realizing that there's going to be a cap there, and just doing the numbers, we see that increasingly we're going to have, in a few years from now, the need to outsource some of the workflows to the IDACs. So especially in computationally intensive workflows. So we have other ideas also of using additional US resources, but definitely just to state that the IDACs is on our minds firmly as the option to do so.
Yeah, it's good to know. So I think having these discussions well socialized and in the open so that we understand what the demand is likely to be is important, right? So that, yeah. Any other thoughts on that point? Oh, right. So how about the second point? So the long-term maintenance of software and derived data products. I think those are brought up in Tom's presentation. What are your expectations there?
Yeah, one thing I've realized I probably should have mentioned, but this is teed it up nicely, is I think we're underusing the Rubin pooled effort For people who might not know, there's in-kind contributions that can be non-directed and directed, which are, you say you want to do X, and either Ruben say, fantastic, just go ahead and do it, or fantastic, go ahead and do it, but we'll iterate between you and your science collaboration. But there's also a third option of pooled effort, which is just, I have a person, or I am a person, I can provide 1 year of computer programmer person who would like it, and then they go into a pool and people can request from that. And it's a different process essentially. But if you are able to provide fractions of a staff person for a decade, that is gold dust. And I don't think we're tapping that resource for things like maintenance of software or the full LSST timeline. So that pooled effort, if there are, I don't know how many people have said, I can do 0.4 FTE for 10 years in this project, but I think Ruben could actively push for recruiting that kind of in-kind contribution, because that fractional effort is all you need. You need half a person to maintain a series of several projects, because each one doesn't take very long. But you just need it for a really long time. So you need stable employment, essentially.
Yeah, that's an interesting point. So I think for the general pool effort that's currently in the Ruben in-kind program, there was a feeling, at least at the start, that the amount of sort of FTEs being contributed on an annual basis needed to be at a minimum threshold. And I want to say 0.5 FTEs per year. But your point is, I guess, that an annual FTE effort of a software professional could be really useful, even if it was quite small for maintenance purposes. Yeah.
Yeah, on this particular point, we found the possibility of adding an in-kind contribution for directable software that's been crucial for a software product that we made at the desk, and that people for different reasons were phasing out, and it's going to be we're going to be able to overlap with this in-kind contributor just in time so that he can maintain the software for years to come. So that's been crucial for us, especially in this context of diminishing also resources for the desk and for everyone in the US, I guess. Also, I wanted to add on the derived data products point. Another thing that we are realizing from the desk is that at some point we want to provide value-added catalogs that are not being, and that's also something we're looking forward to for specialized centers that already have done all the work in providing very nicely catalogs that someone will do for us.
Yeah, that's good points. And again, on the general pool, just want so the general pool resource that we have now, one of the challenges has been matching sort of developer capabilities to the problems being proposed. But I think this maintenance issue is maybe one that we could explore a bit further. And the same, I guess, for the derived data products. Any other thoughts along these prompts? Yeah. Do you want to read it out?
Hello, this is from Dave McKay. Can in-kind code be submitted to the CI tools being used by Ruben, e.g. on github.com/lsst-s, is that square? Okay, even if forked, that's the question.
Yeah, I'm not sure I'm the the right person to, let's see. Yeah, I think man, as a technical question that seems like it should be doable, right? I wouldn't promise anything off the bat, but yeah, it seems like we should be able to solve that. Yeah. Let's see. Let's move on to the next prompt. Right. So there are some expectations, I think, for availability of resources. There's clearly demand from science collaborations, probably from the general user community as well. When we originally put together the list of use cases that were computationally intensive for the workshop that we held now a couple of years ago, I think the estimates for those use cases already subscribed a substantial fraction of what we saw was then available for computing cycles and storage. So I think the demand is going to be high, and the expectation is that the resources will be there. And I think there's expectations now around being able to maintain that and perhaps leveraging some of the in-kind resources to help maintain the software and the data. So given what you've heard now, do you think those expectations are likely to match reality or not? Or are there concerns that you have? Yeah.
What can you say, or what do you anticipate the volume of requests, and how many people will want, and what volume of data involved? And I think that there's this question of whether it meets reality.
Yes. So the workshop that we held a couple of years ago was aimed at trying to to tease out what the demand is likely to be. I think it's still a little bit early to tell exactly how much, but from Nacho, what you just said, that Desk is coming to realize that their demand is going to exceed what they have planned as being available. I guess I see, since Desk is one of the most sort of organized and prepared collaborations, I think the other collaborations are likely to come to this realization as well, maybe a little bit later. But yeah, I think the demand is likely to be high. Now, from Ruben's perspective and Bob Blum in particular, he wants to make sure that these in-kind resources are well used. And I think the science collaborations being the scientific communities that have invested most in LSST, I think should, they have a somewhat privileged position here. So I think if we can come up with a mechanism by which the needs of the science collaborations are mostly met, then we'd be happy. But so.
But the needs of the science collaborations will change. I mean, it's very easy. I think most people are comfortable saying, this is what I'm going to want to do with it. But once the data starts coming, it says, oh, I can do this too. And so it's very hard to estimate.
I agree. And I think, I guess my expectation is that the people will start coming to that realization as they work with the data at the US data or the US Data Access Center. And then once they start running up against computational boundaries and storage and resources, they'll start to look around for what's available. I don't know how that will develop, but hopefully we can anticipate well enough, right, so that we can adjust on the fly. Any more concerns? No? Uh-huh.
One sense of things is if the demand really ramps up fast and that we're seeing that we're already saturating out the resources that we have planned for these. How much room for expansion is there? Are the IDACs sort of like, this is probably all we're gonna be able to do, or we saw at least in the Polish case that there was some looking at enhancement possibilities and things like that. How close to filled of demand, like how much more capacity could even be added if all of a sudden that demand really shows up?
That's an excellent question. And I think there, there are places with some plans. I'm going to point to Poland's IDAC plus idea. I think that's probably indicative of potential expansions across the network. The other thing we should advertise is this resource need call. So if it's clear that there's a resource that the science collaborations or the community needs in order to get their science done and it's not there, it can put in a resource need, and Ruben can advertise this as an in-kind contribution opportunity that the international and the US community can both try to serve. And so yeah, I think we'll have to handle it through a combination of expansion of existing contributions and resource need calls. Yeah.
I just want to add that that's probably very intentional with, in particular, GPUs. Not many IDACs initially presented an intent to have GPUs. We know the environment has very much changed for that. And so we do want to make sure that if IDACs can provide this resource, that it is rewarded as opposed to just throwing money to meet needs without getting anything in return.
Yeah, yeah, great point. And we are right at noon, just passed. So let's end it there. And thanks everyone for their contributions to this session.